Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. So today I've got Ben who has completed the course ROS 2 Basics in 5 days. So what we'll do is we'll first of all get through the details of his presentation, and then later on we'll get to see the demonstration on the real robot. Um, but between then we would have to find out a couple more about how he managed to do his project by asking him a couple of questions. So what I will do now is I hand over the platform to him so he can begin taking us through how he managed to do the project, and then we'll see the demonstration on the real robot at the end. All right, Ben, whenever you're ready, go for it.
Okay, here, as mentioned previously, I'm going to be going over my slides for my presentation first and kind of showing the logic through my code. And then at the very end, I'll be talking about the going through the demo. So, okay, let me see. Can you all see my slides or not yet?
Not yet. We're still seeing your code base and the notes.
Here, let me share my screen. Okay, how about now?
Just one sec. Okay, there we go. Now we can see them.
Okay, all right. So again, hi everybody. My name is Ben Buley, and I'm going to be kind of going through my ROS 2 Basics in a 5 days course. I'm going to talk about the wall finder, the wall following, and the odometry readings. So again, about me, my name is Ben Buley. I am a bachelor student at the University of Houston. I am studying electrical engineering. My concentration is in signals and controls. And also, this is my first robotics course I've ever taken. So learned a lot, got to see a lot. It's been very interesting.
Good, good. Wish you all the
Okay.
best.
Oh, yeah. Thank you. So to kind of give a brief overview, here are some of the project objectives. So the first objective is to find the nearest wall. The robot is supposed to rotate so that it can face the wall, move to it, and maintain a parallel distance to the right wall. The second objective is for the robot to move around the track, maintaining a distance between 0.2 and 0.3 meters from the right side of the robot and the right wall. The robot must turn left continuously to avoid the right wall. That's how I programmed it in my case.
All right.
For the third objective, this was to track the total distance traveled and to have the robot stop once it has completed a full lap around the track. The robot should return a list of odometries being recorded. The robot should stop within 5 centimeters of the starting point, and it must return the total list of points stored in the array. Okay. So to kind of kick it off, some of the comparisons between the simulation and the real robot, some of the ones that I found. So one of the biggest differences was the accuracy of the sensors between the simulation and the real robot.
Okay.
The simulation's laser scan was pretty much perfect most of the time when I was running it. You know, no missing data, no incorrect values or anything. But with the real robot, the LiDAR scans, it could return some inf or noisy reflective readings at some points.
Right.
And this can impact things like wall distance accuracy, and sometimes it gives false positives. For example, like think it gets in a corner when it's not, or my robot will occasionally report inf or have large fluctuations in wall distance. And I'll kind of talk about that when I'm actually demoing, so you can actually see what I'm talking about.
All right. All good. All good.
But yeah, and so the laser scan on the sim, one thing I found is that it's often centered front facing, so from 0 to 2 pi degrees, while the robot's indexing is different from negative pi to pi.
Right.
And this is one of the things that I encountered along the way with my wall following is I used values for the sim, and while it still had wall following behavior pretty accurately, if I had used indexing as listed here, then the odometry readings from the distance to the wall would have been much more accurate.
All right. Okay. Okay.
Yeah. The next thing, to kind of, since we're talking about odometry, is, on the simulation, the odometry was nearly perfect. Had, no drift in the simulation or anything. But on the real robot, there can be drift, and in my case, it affected the lap detection accuracy.
True. True.
At one point. The next thing, some of the dynamic movements in the simulation were sharp, instantaneous. While the real robot, it did have some latency at points.
Mm-hmm.
There were, movement delays. The velocity thresholds, I had to incorporate that just so it could move properly and be timed properly. For example, my recovery turns, they needed slightly more time in real life versus the simulation to be working correctly. And lastly, the distance readings and proximity to the surface were accurate in the simulation. But laser positioning on the robot I used a smooth window to get accurate distance readings. So yeah, they could be inaccurate in real life. In the simulation, it was very accurate.
Right. Right.
Yeah. So next thing, I'm going to be talking about the wall finder and some of the topics and services that were used.
Mm-hmm.
So 4 topics. Publisher was right here, the self-create publisher. It created a publisher to send velocity commands to command vel the topic to control the robot's motion during wall alignment.
Mm-hmm.
My subscriber, or subscription right here, was to laser scan, subscription to the scan topic to receive laser range data from the robot's LiDAR sensor. And this was used for wall detection. Yeah, the services used, this was created a service server for the find wall service. It rotates the robot until a wall is detected on its right side, and then it goes to align to it. Okay. So here is kind of a general overview of how my code works. I'm going to switch my camera in a second to show you my actual code logic behind it, but to kind of give you a description of a very high level description, it's there's import standard messages for movement and perception. Mm-hmm. This is like the core functionality of it all.
Yep.
The node is initialized, subscribers, publishers, services. The service find wall is called to begin the wall finding, and the publisher is then set up for the robot's movements. And the laser scan callback, it updates the self laser data. And then I have a couple functions that were used. The average range function, it minimizes noise in the laser data. I have it centered index to 270, and it corresponds to the right side of the robot. That's one thing I'll show you in the demo, but having proper laser readings or proper laser indexing, that would be able to give me proper odometry readings. And I did have some trouble with this as I was going through it.
Right,
so
right. How did you figure out that was the case?
I noticed because when, for example, and you'll see it all with the wall following behavior, that it will display proper readings. It'll display that it's going along the track properly. However, the odometry readings will be off. Like, for example, it can be very close to the wall.
Okay.
But it'll say that it's like 5 meters away, for example.
Okay.
So if I had used like the 180 to 180 index readings, then I know that would have solved the issue. That would have made it accurate.
All right.
So then there's the find wall callback. It checks if data is available. It rotates the robot clockwise while detecting right laser scan data, and it stops within when the wall is within 0.3 meters, and it times out if no wall is found after 10 seconds.
Okay.
The reason for that is because when I was going through the code and it would just check to see if it was 0.3 meters, it would almost be caught in a loop and it would just be spinning.
Okay.
So if I had a proper timeout with a with that duration of 10 seconds, then it gives it enough time to detect the wall.
All right. So what would happen
Um,
after the timeout hits? Would it retry, or you would have to retry manually?
I I was working through the numbers. I started off with 5. It wasn't working enough. I
Okay.
found that 10 to be the perfect amount. I
Okay.
suspect that if it still didn't, I would probably have to redo it manually.
Okay. Okay. Okay.
Yeah,
I see.
yeah, yeah. Next, once the robot is in range, it stops turning and it's a line to the right wall. So now I'm gonna change screens again, and I'll show you the wall finder code.
Okay.
Let's see, share. I guess I could do a tiny screen. Okay, there. Okay, can you see my wall finder PY?
Yes. Yes, we can see it. Yes.
Okay, perfect. So as mentioned, this is the very beginning. So this is a kind of quick overview of how the code is set up.
Mm-hmm.
Um, so standard messages are right here for things like RCLPY, the wall finder service, the wall finder class right here.
Mm-hmm.
Uh, this is the node, and it's used for creating wall finder. Right here, I have my service. Oh, sorry. My service and topics, and it initializes to 3 interfaces right here.
Mm-hmm.
So this is a service, this line right here. External nodes call to this to trigger the wall finding. Right here underneath,
Mm-hmm.
this is a publisher. It sends velocity commands to actually move the robot. Right here's the subscriber. It listens to the laser scan data from the LiDAR data.
All right.
Right here is a placeholder to store the latest scan readings. And there's the message for confirmation. The wall finder service is ready.
Okay. Okay.
Yeah. And right here, the scan callback, it stores the incoming laser scan distance array, msg.ranges, into the self laser scan data.
Mm-hmm.
And this keeps the latest LiDAR data available for wall detection.
All right. All right. So you would
All
process
right.
it from that container then.
Yes.
Okay. Okay.
And the average range, this was what I used to, let me see if I can. The average laser distance over a small window,
Yes.
centered at the given index, and it's used to get a stable and more accurate wall distance. I found that when I used fixed values to determine this, it had a hard time detecting the wall. So
Okay.
increasing the distance over a small window, that really did help. Let's see.
So
Next
so
right here.
so are you
I'm sorry.
saying are you saying that you made the amount of ranges data that you have to process per instance slightly smaller for you to be able to detect the wall?
Yes, when it had an increased range, I found that it would enter like this kind of continuous loop, for example. It would have a hard time detecting the wall, and at points it would just start spinning in circles, kind of trying to detect where it was.
Okay. Okay. So when you made it
Yeah,
finer by taking little and little, all right, that makes sense. Okay.
yeah. Next, the find wall callback. This is the early exit if the LiDAR isn't publishing data yet. So
All
this
right.
this is this is exactly like what goes back to the average range. So if it was not detecting any data yet and it was entering that loop,
Mm-hmm.
um, this is an early exit, just to see if it's not publishing data yet.
All right. All right.
Um,
So
yeah, here's
it's like a safety measure to say if you're not getting anything, then don't process. Don't look for things to process.
yes, exactly.
Okay. Okay.
Yeah. Um, here's an initialized twist message for movement. Um, and right here, it gets the average distance reading from the right side at 270, at 270 degrees.
Uh-huh.
And it logs the initial right side distance.
All right.
Um, and we've been kind of going back and forth talking about this, but it stopped searching after 10 seconds, because if not, it would just be in a continuous loop.
Mm-hmm.
It's going back and forth and never ending. So I put like a way to break out of that.
That, it was very
Um,
nice. It was very nice, actually.
yeah, no, thank you.
Yeah.
Um, and here's a pretty interesting thing. So you'll notice right here, it's like it rotates until a wall is detected within approximately 0.3 meters.
Okay.
However, my right wall distance, I have it listed as 0.5 meters. This is, I believe, I've been talking about this. It's like with the wall finding and the wall following.
Yeah.
If I had used proper indexing from -180 to 180,
Yes.
I feel like this issue could have been mitigated
All right. All
or
right.
prevented altogether.
So you had to make it big on this one to allow for that room for error, kind of.
Yes, I did. Yeah, because otherwise it wasn't working properly. Yeah.
Well, I
Um,
like that. Yeah, I like that. A very good improvisation there.
yeah, it was improvisation, but if I, use the values like -180 to 180, this could have been.
I,
I basically was trying to find a workaround through it.
all right, all right. Good. Do you think you could have done a remapping of it? I don't know. What do you think? This is just me thinking. Now that you say that, would it
I
help
think
if you
it.
had?
I think it would have helped. Yeah,
All right,
definitely.
all right, all right.
Yeah.
Let's go on.
Mhm. So right here, it's just, kind of like the clockwise rotation. Again, it rotates until the right wall is detected.
Mm-hmm.
This is the rate at which it rotates. Right here, RCLPY spin once. This is used to process incoming laser data. And here's the scan message.
Yeah.
Um, here's the timeout message from up above. Right here, it'll stop rotation once the wall is found.
Okay.
So, yeah, and this right here just logs the confirmation. And here is my main my main node. It starts and spins the node until shutdown.
All right.
So let me go through the next one. Can you see my slides? I put it
Yes.
on. Okay, perfect. So now I'm going to be going through the topic, services, and actions for my wall following
Yeah.
behavior.
All right.
So the topics, here's my publisher, the self-create publisher. It publishes velocity commands to command vel to control forward motion, turning and recovery maneuvers while following the wall.
Mm-hmm.
My subscriber, the self-create subscription, it subscribes to the scan to receive LiDAR data, and it's used to determine front, right, and left distances to follow the wall and avoid obstacles and corners. That should not be a slash.
Mm-hmm.
Some of the services, or the service, the self-create, my service client, it sends requests to find wall service to align the robot's right side to the wall before beginning wall following.
Mm-hmm.
And my action client, it sends a goal to record ODOM, the action server, to begin tracking odometry and detect when the lap is completed.
Okay.
Once it's completed, it publishes a 0 velocity message and it sets the flag to stop. It doesn't shut down the node altogether, but it just sends it a message to stop.
Okay. Okay.
And as previously, here's a very high level brief overview of how my wall follower code works. So again, there's the initialization of the publishers, subscribers, and action clients at the very top.
Mm-hmm.
So it'll align the robot to the nearest wall. It will use LiDAR to detect corners, maintain distance from walls, and escape if stuck. That includes like corners or flat wall. And I'll show you what I'm talking about. Not all of the code is necessary for use at this point, like only some portions of it. But as I was troubleshooting and going through the code, there were instances where I got stuck in a corner or head on facing into a wall, and I had to basically troubleshoot ways to get out of those situations.
Okay, I see. I see. That's a very good experience. I would guess having to go through that and figuring a way of going around it. Very very nice. Very nice approach.
It was kind of tedious in the beginning because it would I'd solve one problem, but it introduced me to another one, and I was just like,
Yeah.
oh, okay,
Yeah.
like,
Yeah.
yeah,
It can be frustrating.
yeah. but I managed to get it working. So
It's good.
after that, it's the there's this, it starts odometry tracking, and the robot stops after completing one lap,
Okay.
and
Okay.
the node stays active. So let me go show y'all my wall following. So can you all see my screen? Yeah. So here, oh, okay, we're about to be able to begin showing the demo.
All right.
So right here are all the initialization processes in the very beginning. Here's my my node. My node is named wall follower. So right here at this point, the self lap complete. This is used to shut down the robot once it's completed the lap. The ODOM action client. This is connects to the ODOM recorder to start and to monitor the lap progress that is going through. The command vel, the publisher. This is used to publish the movement commands. The scan subscriber. This subscribes to LiDAR data to make proper decisions.
All right.
And the find wall client. This client is to the wall finding service.
Right. Okay. Okay. I see.
Yeah. And right here, this kind of area right here, these are just kind of a list of the parameters that I used. So right here, these first four, these are kind of target wall distances and, thresholds that I used for movements. Right here, these are like the speeds, like the forward speed of the robot, reverse speed, the turn speed, the recovery turn.
All right, so
yes,
you basically fixed those ones so that you would know every time it goes forward at that particular speed.
Yes, these are all fixed values that I use for these.
Right. Okay.
Yeah, and here I use the timeout and dead zone values for cleaner control because I did incorporate proportional control.
All right. All right. So the dead zone is like, can you explain a little bit more what that means, or how does it affect the controller?
So I've found that once because the robot will be in a way continuously at a very smoothish way, constantly going towards the right wall. Then it'll incorporate a left turn command where it'll readjust, go outwards. This dead zone basically is an area along the track where the robot doesn't detect. What it'll do is it continuously go, and it gives it smooth behavior while going along the right wall.
So it's smooth.
That's one of the best ways it helps.
The trajectory. So are you saying that it's during the course of the dead zone, it's not supposed to be making any either 10 right or 10 left kind of maneuvers? Is that?
Yes, that's exactly right. Because if it was, I had to incorporate it kind of early on because I found that if not, it would be going along the right wall, and then it would, even if it's fairly close to it, it would begin turn left behavior, and it would make it very jagged. It would make it very jagged behavior.
Okay.
So, and I did mess around with the fixed value. I've noticed that, if I used 0.05, that would make it the dead zone a larger value.
Okay.
But if it was too far of a value, it would actually stray too far from the right wall.
Okay. Okay.
Yeah. So if I have it among this specific threshold, it's a good balance between staying close to the right wall and not deviating too far.
All right. So this number is basically empiric. You had to acquire it through trial and error, kind of.
Yes. Okay. Yes, I did.
All right. All good. That shows a lot of work there. So well done on that bit. Very good.
Yeah. And then right here, this is the flags for managing state values. And here's the get logger, the wall follower node is started. So upon startup, the robot it first aligns with the wall before beginning wall following behavior. Right. And here's my odometry recording. It triggers the record odom action. It waits for the server information, and that then goes to the goal response callback, it sends a goal. It determines if the ODOM goal was rejected or if it was accepted.
All right.
One right
Ben, I
here.
think you must try to do the demo now. I think we
Oh,
should
yes, it's 11:30.
be on time. Yeah.
Okay, perfect. Thank you for reminding me. Okay,
Sure.
I'll do that right now. Yeah. Yeah, thank you for reminding me. If not, I would have gone on.
Oh, good. Oh,
Okay.
good.
Yeah. Okay.
All right.
So here, let me bring it to its starting point. Okay. All right, let's start it from right here. And I'll talk about a little more of some of the things, little quirks that I might have encountered along the way.
All right.
Okay. So I have these preset just to save time.
Okay.
Okay, let me see. Oh, okay. Okay, here we go.
Okay.
So here is reversing. So if you'll notice within the odometry readings, they'll say it's too close.
Okay.
Here. Detection corners, it goes head on.
All right. So it actually stops before making the turn. It doesn't rotate as it moves forward.
Yes.
All right. All right.
And here's the, if you can kind of notice the dead zone thing I was talking about. So right now it's within the dead zone and it's basically doing small deviations
Okay.
towards the right wall as it's going.
I see.
Yeah, so it's turning, it's within dead zone and it just continue going. It's within the threshold of it
All right.
until it's not, until it's facing the right wall.
Uh-huh.
Let's see how it does it with the obstacle right there. Okay, perfect. Goes through, it's within the dead zone range right now.
What do you
And
think
then
might have been
detects,
happening? What do you think might have been causing it to veer off course like that, slowly like that?
so you mean towards the right wall?
Yeah, yeah. What do you think might have been? Because it's like it's getting different velocities for the right and left wheel, right? If you were just to look at it, right? So I just wanna hear what your thoughts about it is.
Yeah, so I found that when it was fixed values for velocity and it was deviating towards the right wall. Oh,
So it's like it's almost like you're taking away the permission for it to do the regulation on its own. So more or less, right?
Yeah. So that obstacle kind of threw it off course a little bit.
I see. So
Here.
it still does not
Here.
recognize that it's close to the starting point, right? Because you're not within the 0.03 yet.
Here, let me show you because it does detect it. It just that obstacle that was in the way kind of prevented it from, like it kind of threw off the readings, I suppose. I hadn't seen that before. So if I was to restart it, put it along the same path that it was traveling,
Yeah, I think
right
I
here
think it's
for.
all right. Let's rather get into the questions so that we will be on still on time. Okay. So I think you can
Okay.
stop it, or maybe yeah, just stop it for so long, and then I'll get to ask you a couple of questions before we wrap it up here. So my first one
Okay.
is you spoke about using services, right? So the first thing I'd want to know, um, why did you not use an action for your find wall, for example, right? It's the kind of thing that I would want you to be able to explain. What is the difference between an action and a service? Um,
Okay. So I guess it would be best to use a service for that type of behavior because it's like a one-time request and like a node will call to like a service and another responds and it's used mainly for short tasks I found. So like triggering behavior or asking for information
mm-hmm.
and wall finder is best for that. If I had used an action that's similar to a service but it's for longer tasks
All
like
right.
used in like navigation
I see.
or like in odometry recordings, that would be a situation where it'd be best to use that.
All right, that's good. The extra bit that I wanted is the fact that when you do a service request, right, the client has to wait, whereas in action, there is not necessarily that waiting, right? It's like with the service, it has to wait, so that in that process, it blocks everything else to wait for that response to come in, right? So that's an
Yes.
important point to also take note. The next question is. How do you differentiate the client and the server, right? Because you do have both of them in actions and services, um, but it is important to understand who is what, right?
Yes. So differentiating those two, um, it really depends on the tasks I found.
Mm-hmm.
So um, again, if you're dealing with a task that has to deal with not necessarily one stream commands because that would be more topics, but if you're dealing with synchronous response time or short tasks, then it would be best to incorporate clients for that. Or service clients for that. If you're doing an action client, it would be for things that require a lot more, like a lot more, like a lot longer of a goal.
All right. So basically, the client is the one who get their response from the server, or who sends whatever they want to the server. In both of them, right? So if
Mhm.
it's an action, you are sending whatever is supposed to be done over a period of time to the server to say, okay, do this and return something to me, or return a preemption, right? Yeah, if you're dealing with
Right.
actions, say, oh, I didn't manage to do this, so I will stop here, and you tell the client that, right? All right.
Yes.
Let me see if I have any other question. All right, I think that's it from me. I would like to congratulate you. Very nice presentation. Loved the
Thank you.
details. You did go through quite a lot, and we don't want to go off too much of the time that we've got now. But it was a very nice presentation. So well done on that, Ben. Um,
All right. Thank you
so,
very much.
sure. Can you just hang on, and then we'll wrap it up here, and we'll finish our meeting on Zoom. Okay.
Yes. Sounds good.
All right. Alright, everyone, so this was Ben's presentation, a very nice one. He did get into the details quite slowly and very clear. So to those who would want to take some of the courses we offer certification on, I highly encourage you to do so. And until then, keep pushing your ROS